Hey everyone, my name is Alade Jedari. I'm representing Business Education Group 4. We are here to talk about the module, database and data warehouses. The learning objectives are information resources, database advantages, relational database, data warehouse, distributed database, and information management. What are information resources? Information resources can be defined as database and information used by an organization in their day-to-day activities, and this also represents the hierarchy of what they use to make their business flow and make everything come together in place so as to make the business flourish. What is structured information? Structured information are highly organized and standardized formats used by an organization in providing a page for their employees. It can be by an organization to represent the employee's biodata, which represents the name of the employee, the age, the phone number, the street name, and other information about the employee. And it can also be used by banks for their customers too, if they want to state their names, their age, their street phone number, and so on and so forth. Unstructured information. These are informations that don't have any structure or inherent and cannot be easily linked together. The examples of this unstructured information can be the text, your sticky notes, your Twitter feeds, and also Facebook messages. They do not have any structure. They have no head or no tail. So they do not state where they are going from or where they are ending. Semi-structured information. These are a type of information that combines both the structured and the unstructured information. The metadata information. The metadata information clarifies the nature of an information. It's also the combination of the unstructured and the structured information. For example, properties of a document on a computer system. A metadata can be used to indicate a file location, like a file location, on the computer system. The file locator will help you indicate where the data is. The search button on the computer system just indicates the data you want to find. Once you put it there, you click it, it will bring it out. That is what metadata represents, and that is what you use for by most companies to find the employees. Like a large organization now, if they have several employees up to 1,000, they may say, okay, I want to find so and so. I want to find his data, his biodata, and everything that he has, all his personal information. So they'll just click on the employee's name and it will bring out everything that the employee represents for. And also it can be used for the bank too, mostly by the bank. What are the qualities of information? The qualities of information are accuracy. This represents how an information must be correct and also how the information must avoid mistakes so as not to reduce the quality of an information. Completeness. This refers to how an information is comprehensive enough, and also if it is not comprehensive, it might not be usable by any organization or any individual. Timeliness. This is how up to date your information is or how relevant it is to the organization as it matters to time. Bias. Information must not be biased. When it takes objectivity and when it lacks objectivity, it will reduce the quality and also the trust in the person you are giving the information to. Consistency. If it is written, information must always be valid according to set and defined rules of the organization you are representing. Precise. This also represents the accuracy of the information as it is in the first line point I gave to you.
Managing information. Information management is the range of technical, operational, and social functions used to handle information for individual, government, or organizations that have anything to do with information. Record. A record is a row in a table that represents an entity. The attributes of a record. What is a field? A field is an attribute of a record that contains numeric data, text data, alphabet data, or a combination of two. A field should have data definition that specifies its characteristics, such as the type of data, the minimum and maximum number of data that you can hold. File processing systems. File processing system, also known as FPS, is a way of storing, retrieving, or manipulating data which represents various files. The advantages of FPS as follows: redundancy, inconsistency, lack of integration, inconsistent definitions, and dependence. Redundancy and inconsistency. Redundancy and inconsistency is when two or more data or information appears in a particular document. It is also a set of computer programs which is operated in its own record, whereby where too much information are involved, it becomes redundant and inconsistent. Lack of data integration. Integrating data from the separate system is always a struggle when retrieving or manipulating data. Inconsistent data definitions. When programmers write code to handle files, data definition may seem similar across systems, but when they are used differently, the summaries can be misleading. Data dependence. Maintenance is always difficult because programs and their files are so interconnected and dependent on one another. Disadvantages of file processing approach leads to a better way of organizing structured data, one that relies on database. Database management software, also known as DBMS. DBMS is a software that manages the database and provides tools for ensuring security, replication, retrieval, and other administrative and housekeeping tasks. Database management software serves as a gateway to the database and as a manager to handle creation, performance tuning, transaction processing, general maintenance, access rights, deletion, and backups. The database is an integrated collection of information that is logically related and stored in such a way as to minimize duplication, facilitate rapid retrieval, and its major advantage over FPS is reduced redundancy and inconsistency, improved information integrity and accuracy, improved ability to adapt to changes, improved performance, scalability, and increased security. Reduced redundancy and inconsistency. It is a process whereby inconsistent files and files that appear twice and takes larger space are removed and reduced. Increased security. DBMS has a safer way of storing data, retrieving data, or manipulating data. Improved ability to adapt to changes. Database management software makes changes easier and performance and scalability easier. Also, improved information integrity and accuracy. When using database management system, improved information integrity and accuracy. Database management software improves information integrity and makes data which are either retrieved or stored very accurate.
Database architecture. Firstly, what is database? Database is a collection of information that is organized so that it can be easily managed, accessed, and updated. Database architecture. Database architecture is a method or structure used to represent information or data. The relationship types. We have three relationship types of database architecture. So one-to-one structure, one-to-many structure, and many-to-many structures. So as you can see in the diagrams, the one-to-one structure, we have the employee's identification number and employee's date of birth. So one-to-many structures, other than one-to-many structures, the employee's identification numbers shows different dependent names. And many-to-many structures, under many-to-many structures, we have the employee's ID with different project ID. So there are many project ID, like 555 representing different project ID, like 10 to 11 project ID. Relational database. Relational database organize data into tables that can be linked or related due to common data on each table. Relational database. We have two tables under the relational database. So the first one is students. It shows the student's record, and the second one shows the student registration record. So under the first one, we have the student's ID, we have last name, first name, and date of birth. While the second one shows the student registration ID, student registration numbers, student ID, class code, and grade. So as you can see, in the first tables we have the student ID there, and the second tables also include the student ID. So it shows the link between the two tables due to the student ID that appears in the two tables. Data model for relational database include uniqueness, attributes, primary keys, and normalizations. Normalization is the process of refining entities and their relationship, and it helps minimize the duplication of information into table. Data model 2:2. When a primary key appears as an attribute in a different table, it is called foreign key. Normalizing the employee table by removing department phone A and placing this field in the newly created department B.
Retrieving information. Most people access database through an application interface with users-friendly web-based form to secure, enter, edit, delete, and retrieve information. The web-based form simply accessed by customers, suppliers, and staff with appropriate security controls. Although the application software can be developed in a number of programming languages, Structural Query Language (SQL) is the most popular. SQL uses queries to retrieve records, insert and edit data, and delete records. That platform for application software includes Interactive Voice Response (IVR), which uses signal transmitted via phone access to the database, retrieve account information, and enter data. Natural language queries that response to spoken or typed language are also improving, especially from narrow domains and database with limited vocabularies. The data warehouse. The data warehouse is a central data repository containing information drawn from the multiple sources that can be used for analysis, intelligence gathering, and strategic planning. Building a warehouse for operational database and adding some external sources are manageable for most organizations and extremely useful. Consider also how much semi-structured and unstructured information flows for like Twitter, YouTube, Instagram, Facebook, and many other social media platforms, some of which could give the company a competitive advantage if analyzed quickly. The amount of data available is also exploding because so much is gathered automatically by sensors, cameras, RFID readers, and mobile devices. Big data refers to collection of data that are so numerous in size, so varied in content, and so fast to accumulate. They are difficult to store and analyze using traditional approaches.
I'll be talking about the relationship between distributed database and blockchain.
Supercomputers have their limits, so designers launch distributed database in which all or portions of the database are located on separate servers to distribute processing loads and improve performance. A distributed database may involve many servers so that large numbers of customers, suppliers, and staff members can access information they need in a timely way. One strategy is simply to replicate the database on several different servers on a frequent schedule so that the user traffic can be directed to one of several different servers. The system may be in the same data center, but they might not be located on different continents to better support users across the globe. Another strategy used to accommodate increasing load is to fragment the database so that the portions are stored separately on different servers. This way, each servers only needs to respond to queries that involve data stored on that server. Regardless of which architecture is used to create a distributed database, the design must ensure the integrity of the data in case conflicts arise, especially when adding or deleting data. A distributed architecture that is gaining considerable attention is the blockchain, which can be described as a type of open and distributed ledger in which individual records called block contain a timestamp and reference link to previous transactions to prevent tampering and to ensure transparency. Blockchain first earned its fame because of the technology it used to record transactions involving bitcoins, which is an unlike cryptocurrency that is not issued by the government and instead is value based on market demand. That blockchain was designed to be public so that the people could submit transactions anonymously. This makes them difficult to trace, a big plus for criminals.
Human element 1:2.
Although a company may set the policy that all information resources are company owned, in practice, people often view these resources more protectively, even when compliances and security don't demand tight access controls. Norms about how records are used emerge over time, and though many are unwritten, these norms can certainly affect employees' behavior. Although the integrated enterprise database is a critical resource, changes to support new features can be painfully slow. People want to get their jobs done as effectively as possible, and sometimes the quick solution is to create a shadow system. These are smaller databases developed by individuals or departments that focus on their creators' specific information requirements. A broader strategy to address underlying inconsistency is in the way people use data is to master data management. This effort attempts to achieve uniform definitions for the entities and their attributes across all business units, and it is especially important for mergers. The most successful efforts at master data management focus mainly on a key area such as customers or on a limited number of entities that are most important. Teams from across companies meet to identify the differences and find ways to resolve them. Data stewards may then be assigned as watchdogs and bridge builders to remind everyone how the data should be defined. Master data management has less to do with technology than with people, processes, and governance. Another example of how human element interacts with information management involves database without boundaries, in which people outside the enterprise enter and manage most of these records. These contributors feel strong ownership over their record. A value lesson from the efforts to build database without boundary is simply the need to plan for high volume, rapid growth, and potential abuse. Top-level management needs strategic information and insights from big data along with accurate enterprise-wide report to balance the information needs of many stakeholders. Operating units must have reports on transactions that match their operations, and they need information systems that easily change to support fast-moving business requirements. So in this module, we have been able to learn about the information resource, and we learned that information resource can be defined as structured or unstructured or semi-structured, and we also learned that metadata provides details about information structure and properties. Information quality is affected by several characteristics such as accuracy, completeness, and timeliness. Database approach creates a shared resource with minimal redundancy. So we also learned about relational database. The development of a relational database begins with the planning phase to identify the entities, their attributes, and their relationship. The process involves normalization, in which tables are created in such a way to eliminate redundancy as much as possible and ensure that tables can be related to one another in a way that reflects their actual relationships. We also learned about the data warehouse, and the data warehouse is it draws information from multiple sources to create one information storehouse that can be used to report and it can be used for reporting and analysis. Then we talked about distributed databases, which are frequently required because of the sheer volume of data and the growing number and geographical spread of users and the limits of individual servers. Then we also learned about information management. So enterprise information management is not just about technology. It involves a variety of challenges that touch on the human elements, leadership, cooperation, negotiation, and a well-designed database are all needed to balance all stakeholders' requirements. In the UK police case study, almost every city in London is under constant video surveillance. The cameras are equipped with automatic number plates recognition, ANPR, which use optical characters to recognize and decipher license plate numbers and letters. So a car can be moving and the camera is able to pick the plate number from the car. So the camera data is sent to the National ANPR data center in North London, which also houses the police national computer. Police on the beat can query it to see whether a nearby vehicle is flagged for some reason. Cross-checking the license plate information against the criminal database can turn up vehicles involved in crimes or register to wanted criminals. Beyond criminal activities, the police database contains intensive information linked to the license plate data. For instance, a car might show that it is registered to someone who owes parking fines or who is uninsured. The data are maintained for several years, creating a rich repository for analysis. Private advocates, however, are concerned about mounting the power of integrated database and surveillance technologies to scrutinize human behavior. The United Kingdom is tightening regulations to provide better protections for citizens in an attempt to balance privacy concerns against these enormous values this database offers to law enforcement. So we'll also be talking about the Walmart blockchain chase, and we'll be highlighting the risks to public related to phone-borne emails, Walmart using blockchain to track shipments, and expansion expected, and many other companies follow suit. Contaminated food poses very serious risks to the public, and outbreak traced to particular restaurants or grocery stores are not just financially costly. Estimates from the US Centers for Disease Control and Prevention indicate that nearly 50 million people are affected by foodborne illness every year, with thousands of deaths. Walmart is pioneering partnerships with its suppliers and IBM to keep track of produce and meats throughout the supply chain using distributed blockchain technology. The goal is to authenticate and document every stop along the chain for each package of food, beginning with the original grower or rancher and extending to each wholesaler and retailer. The source, the history and movement of each package will be transparent to all the parties involved, and transactions cannot be deleted or altered once they are entered. In principle, the source of any contamination should be identified in seconds rather than weeks or months, so that the problem can be addressed immediately. Walmart pilot tests involved tracking lettuce in the United States and also pork products in China, but plans calls for greatly expanding the use of IBM blockchain technology called IBM Food Trust to improve food safety. In fact, many other companies involved in food production and distribution have signed on, including Dole, Nestle, Kroger, and Unilever. As the ecosystem surrounding the use of blockchain to track food throughout the supply chain grows and develops, we should see much faster and more targeted response to any sign of contamination.